So again, good afternoon and welcome everyone to our webinar today, which is titled Discover the Power of Houston Radar. It's great to see so many people joining us today, and we really appreciate you taking time out of your busy day to attend. My name is Harrison. I'm an account manager here at Stinson ITS, and I was really excited to host this webinar. I spent my whole career in the traffic industry, and much of that career was focused specifically on selling, installing, and supporting traffic radars. When I joined Stinson and began learning more about Houston Radar, I was truly fascinated by the flexibility and power of their solutions. So I wanted to host this webinar so I could share that information with you on how Houston Radar has modernized traffic data collection. Before we get started, on the right-hand side of your panel, you do have a questions tab. So any questions which come to mind during the presentation, please feel free to post them there. And at the end, we'll jump into that section, and it will be great to have a whole list of those waiting for us when we get to there. And one reminder, we will have a quiz at some point during this presentation, and the correct answer will receive a nice bundle of Stinson goodies. So please pay attention, and when we get to that section, I'll give everyone adequate time to write their response. If you haven't heard about us before, Stinson ITS is a manufacturer, distributor, and systems integrator of intelligent transportation systems. We work closely with our clients through every stage of a project's life cycle, from early design consultations to implementation, long-term operation and maintenance. We fully support our clients with turnkey solutions. We've also been a distributor of Houston Radar sensors and products since 2017. Houston Radar is a leading manufacturer of Doppler and FMCW traffic management radars. All of Houston Radar's products are designed and manufactured in Houston, Texas. A common theme you'll notice with Houston Radar systems is that they feature high levels of integration, ultra-low power consumption, and incredibly user-friendly features. Houston Radar has revolutionized the market with tools that enable traffic professionals to maximize efficiency and confidence when gathering traffic data. However, it's not always been this easy to collect traffic data. Since the 1930s, traffic data collection has been an integral tool used by municipalities to help make decisions related to their roadways. In the 30s, the collection method was typically manual counts. However, in the 40s, there was a transition to mechanical measurement, and in the 70s, computerized pneumatic tubes revolutionized the traffic data collection marketplace. And now today, 40 years later, radars, video processing, and artificial intelligence are once again revolutionizing traffic data collection, increasing reliability and cost effectiveness. In recent years, however, radar has seemed to take the lead as the most used form of non-intrusive data collection technology. And this is because radar has several inherent advantages over competing technologies, with the most important ones being reliability in all weather conditions, highly accurate vehicle speed measurements, and of course, data privacy. Companies like Houston Radar have taken the technology and developed it to target specific needs within the traffic industry. In this webinar, I will explain how Houston Radar has modernized traffic data collection with simple, fully integrated solutions engineered for ultra-low power consumption, high data accuracy, and ease of installation. We will review how different radars can be used for permanent or temporary traffic data collection studies, and how cloud-based data collection is becoming a cost-effective solution for year-round access to continuous traffic data. We have a lot to cover today, and I will do my best to cover everything in the 45-minute time slot. Firstly, we'll review the Armadillo tracker. This is a small, lightweight, low-power Doppler radar suitable for both temporary and permanent data collection applications. The device boasts incredibly accurate speed measurement and is often used as a tool to guide traffic calming or enforcement measures. We will then take a deep dive into the SpeedLane Pro, which is a highly integrated ultra-low power side-fire radar. The SpeedLane Pro provides accurate, in-depth traffic statistics across upwards of 16 lanes and is typically deployed along highways or high-volume collector roads. And finally, we will showcase our client success with Houston Radar solutions by reviewing 3 unique case studies. Now let's get started with our first topic of discussion today. At its core, the Armadillo tracker is a radar-based traffic data collection device. It supports multi-lane vehicle data collection, gathering statistics in 3 categories: per vehicle speed, volume, and 3 levels of classification, including small, medium, and large. Volume accuracy hovers around 96%, classification around 90%, but where the tracker really shines is in its speed measurement, where it is accurate to plus or minus 1 kilometer per hour or within 0.4%. The device is fully integrated, meaning its battery, mounting bracket, Bluetooth receiver, or optional modem and SIM card are all integrated within the device's housing. Not only is the tracker incredibly well integrated and accurate, but it is also very user-friendly. It is the world's smallest, fully integrated multi-lane traffic radar, weighing only 3 pounds. This means maneuvering or mounting the device is incredibly simple and can be safely done with 1 person and a stepladder. It also features a very simple point and go installation procedure, meaning there are no measurements or trigonometric calculations required to set up the tracker. Simply follow a few basic mounting guidelines and you can begin gathering traffic data in minutes. And finally, what I would say is the most important user-friendly feature is the ultra low power consumption. The device only consumes 0.2 watts of power, which is roughly 10 times lower than the closest competing product. This extends our battery life to roughly 2 weeks. And when paired with a small 10-watt solar panel, as you can see in this image, the device may be powered indefinitely. Ultra low power consumption also greatly reduces the weight of the tracker, as we don't need multiple heavy batteries to account for higher consumption. Tracker deployments generally fall into 2 categories: the portable battery operated applications, or solar cloud connected applications. For battery operated deployments, we use the Armadillo tracker's internal battery, which can power the device for up to and over 2 weeks. Between deployments, the data is pulled, the battery is charged, and then it can be quickly redeployed for the next project. Typical applications for this configuration include spot speed studies, ADT studies, or to validate and address citizen complaints. Data can be accessed either over a Bluetooth connection or by plugging directly into the device. Then, using Houston Radar's free stats analyzer software, the data can be analyzed graphically or through CSV exports. If you're looking to extend the length of deployments past the 2-week period, then consider using the 10-watt solar panel or battery booster pack. For the next application, the cloud solar connected option, the tracker is deployed with its built-in modem and SIM. It includes the 10-watt solar panel and a subscription to Houston Radar's Tetrion Cloud. The 10-watt panel powers the tracker indefinitely, and utilizing the built-in modem and cloud connection, data can be pulled from the device remotely from the comfort of your office. This creates a very cost-effective and simple data collection station, which has the added benefit of portability. No external cabinets are required. All hardware is integrated within the device enclosure. Over the past few years, data collection and cloud storage fees have dropped substantially in cost. A 1 gigabyte per month SIM card is more than enough data for the tracker, and this costs around $200 per year. Stinson ITS, we also host our own instance of the Tetrion Cloud, and because of this, we can offer very affordable subscription fees for cloud service. So if you're a smaller municipality, don't immediately assume that a cloud-hosted solution is out of reach. In fact, a cloud-hosted Armadillo solution could very well save your municipality more resources when factoring in manpower, fuel, for locally pulling the data from non-cloud connected sites. Now I'd like to take a deeper dive into the tracker's operation and address a few frequently asked questions. The radar inside the tracker is a 24 gigahertz Doppler radar. With Doppler radar, objects are tracked as they approach or depart the radar's field of view, hence the name the tracker. This means the tracker should be aimed down the road, facing, approaching, and receding traffic. In terms of mounting and installation, tracker should be mounted anywhere between 6 to 9 feet high and offset from the roadway anywhere between 0 and 12 feet. This is a general rule of thumb, and we have seen cases where exceeding the 12-foot mounting height, the 12-foot offset, and adjusting the mounting height in lower or higher than what I mentioned there previously, still produces accurate results. So please feel free to consult us if you have a non-standard mounting application. The tracker itself is a very small and discreet device. It's about 5 inches wide, 5 inches long, and 7 inches tall. Combining its lightweight, discrete profile, and small dimensions mean the tracker can comfortably mount on almost any street sign or traffic pole, street light. Additionally, the tracker is a very benign device, often going completely unnoticed when mounted. This not only protects the tracker from vandalism, but it also produces unbiased speeding data as drivers are unaware they're being monitored. The images on the left-hand side of the screen show the two most common configurations for the tracker. When deployed on the side of the road, the tracker will measure data in 2 lanes, unidirectional or bidirectional. When deployed in the median, the tracker can measure 4 lanes bidirectional or unidirectional. Now I want to address a few of the most commonly asked questions regarding the tracker, with the first one being, how do I configure the device? This is a very common question, and the simple answer is there is no configuration required. The longer answer is the tracker includes built-in configuration templates for the 2 and 4 lane configurations. To begin collecting data, simply mount the device following our guidelines for height and offset, and then power the device on. Data reported from the tracker will consider the direction of vehicle travel, incoming or outgoing, and then automatically assign a lane number and direction. For instance, using the 4-lane configuration as an example, lane 1 incoming would denote the closest incoming lane to the tracker. Lane 1 outgoing would denote the closest outgoing lane from the tracker, and then this convention is repeated for the furthest lanes, assigning lane number 2 outgoing and lane number 2 incoming. Another commonly asked question is, if there's no configuration, then how do I know the tracker is detecting traffic? And I think this is a great question because as a former tech, I've spent many hours in the field configuring traffic devices, and viewing the configuration file is how I used to validate that the device was functioning correctly. With the tracker, again, it is so simple to confirm data collection. During the first 5 minutes after powering the device on, the tracker will produce audible beeps, which sound every time a traffic detection event is registered. So, to confirm that you've correctly deployed the tracker, simply wait next to the device, watch traffic, and wait to hear beeps to confirm detection as vehicles pass by the tracker. The next commonly asked question is, where can I deploy the tracker? The tracker is designed to measure free flow traffic, so it's best to install the tracker at the mid-block, away from any stop signs or intersections. The idea is to avoid measuring any vehicle queuing events, so pick locations upstream and downstream of intersections where vehicle queues don't typically occur. Another question that we find is asked fairly frequently is which classification categories are supported? With the tracker, classification bins are factory set for 3 sizes: small, which include motorcycles and smart cars; medium, which includes sedans, pickup trucks, vans; and large, which include trucks, delivery through 18-wheeler. When designing the Armadillo, Houston Radar prioritized for low power consumption, ease of installation, and accurate speed measurement. In short, to accommodate for more classification bins, sacrifices to these core features would have to have been made. Think of classification as a value-add feature suitable for vehicle composition estimates. Now, I want to do a brief demonstration of the Houston Radar Stats Analyzer software. This is free local data collection software, provided again free with all Houston Radar products. You can also go online and download a copy for yourself. It includes raw event-based reporting data, along with over 40 unique reporting templates. So when you first open the Stats Analyzer software, you will see a dashboard with a list of project files. These files are where data from your previous tracker deployments are stored. Once you access a project file, as I'm going to do now, you will see a calendar in the center of your screen with bolded dates. These dates indicate where data was collected, and on the right-hand side of your screen, you will see several different options for analyzing the data. For this example, let's assume that we've received a whole host of citizen complaints about speeding along a 2-lane rural road. We've deployed the tracker for a week-long study, and now we're analyzing the data. Let's assume the speed limit along this road is 60 kilometers per hour, and we can configure that here on the right-hand side. And what we're interested in determining are the citizen complaints justified? You know, is there actually a speeding problem on this roadway? And if we do detect one, we want to find out when it's occurring, when it's the worst, and how many offenders are there. Once we understand the data, we can use it to justify our response to the complaint. So to run a report, I'm going to click on the bolded dates. And then let's run an analysis report. So it'll take a few seconds, but once we access the report, the first one we will see is a volume report for the incoming lane. And we can change that to the outgoing lane by clicking on this tab right here. So right now we're seeing volume for the incoming lane. Across the top of this report are the days of the week, and then the weekly average volume, and the weekend average volume, and the weekday 85th percentile average speed. So looking at this report, you know, seeing the volume is great. We can scroll down and sort of conclude that the days where the volume is the highest occur between 2 p.m. and 5 p.m. Pretty much for every day, with the weekends being especially busy. But for this example, we want to understand vehicle speed. So what we should do next is run an average speed report. So running the average speed report, we can see hourly average speeds, and they begin to pick up a little higher than the posted speed limit, again around that 4 p.m. or 2 p.m. to 4 p.m. time slot right here. And we can even see that the weekend is posting especially high average speeds along with 85th percentile speeds. So now we already have a bit of a clue where to look into this chart, and that, you know, 2 to 5 p.m. is a pretty rough time for speeding. But what we want to really find out is how many speeders are occurring and at what time. So let's run another report called the show speeder count. When I run the show speeder count, it will show me, it will use the programmed speed that I put in earlier to drill down into the data and find out exactly how many vehicles were traveling over the speed limit and at which hours. So again, looking at our 2 p.m. to 5 p.m. time slot, we can see that there are a lot of speeders, but we don't know the severity. These guys could be going a few kilometers over the speed limit. They could be going wildly over the speed limit. We need more data granularity to direct our enforcement or countermeasure. So why don't we export this report and look at a histogram chart. So we're exporting the report. We'll bring it into a file that you can provide to, you know, a third party, maybe council, maybe the complaintee, or the local police department. And the exported report includes a whole lot of great data to, you know, measure traffic volumes, address complaints, or guide enforcement opportunities. But for this report, I want to specifically look at the histogram chart. Now, within the histogram chart, across the top of the report, you will see speeding bins broken down into 5 kilometers per hour bins. And along the top and bottom of the chart, you will see the days of the week broken down into hourly bins. So, you know, even just looking at this report right now, you can see a lot of potential for guiding enforcement opportunities. I can see exactly how many cars were traveling at what speeds during what times of the day. So I want to take the worst day for speeding, which was Saturday, I think. So let's scroll down this report to the 7th. And let's look at the 7th at, let's say, 4 p.m. right here. Now, looking at this report, we can see that there's a few vehicles traveling wildly under the speed limit, but as we creep closer to values which are above the speed limit, it starts to get really really bad. There's 33 vehicles traveling between 70 and 75, 20 between 75 and 80, 7 between 80 and 85, and we even have a couple reaching over 90, between 90 and 95, and then even a few, 2 vehicles to be precise, traveling between 95 to 100 kilometers per hour. So we can conclude that there is a speeding problem here. And this report also includes some other great information as well that could be useful to stakeholders. But just by looking at this first set of histogram data, we have a lot of information to go on right now. So because we have the data, there are now a variety of solutions that we can explore to slow drivers down. First of all, we can do something basic, like install a driver feedback sign or rotate an existing one to this location. We could print this report and share it with the local police, letting them know exactly where and what time they should direct their enforcement actions. And this is great because it conserves resources. It tells the police exactly where and when to be to catch the speeders, and they're not doing any guesswork. And finally, we could also, if your municipality was participating in the automated speed enforcement program, we could move a speed enforcement camera to this location and basically guarantee that it generates revenue. So those are a few options we could try, but really what I want to nail home here is that we need the data to really maximize the potential of our enforcement or countermeasure opportunities. And using an Armadillo is a very easy way to get this data because it's not going to be biased. It's incredibly easy to rotate an Armadillo into this location for a week and then pull the data back. And then you can take these reports and highlight them and send them directly to stakeholders, counselors, the citizen who filed the complaint, or of course the police department. And I strongly recommend that you share the information from this webinar with your local police departments and let them know that there is a tool out there that can very easily assist them in guiding enforcement opportunities. So now I don't want to spend too much time on the software because we do have a limited amount of time today. So I want to get back into the presentation. And our next slide I want to highlight is on a case study that we did for the town of Blue Mountain. It was a somewhat large-scale Armadillo deployment. And if you're not familiar with the town is a rural municipality located in southwestern Ontario. And the town purchased around 10 solar cloud-based Armadillos and 2 portable battery-operated ones. In the images here, you can see some of the Armadillos were deployed using newly installed 12-foot wood posts, but the majority of the deployments used existing electrical or streetlight poles. The systems were installed in 2021, so we've had a full year of continuous operation, and so far everything has been working very smoothly with no solar outages. And just if you're not aware, the town of Blue Mountain is actually quite large. It's larger than I initially thought. I have a map right here, and the town stretches from Thornbury down to the resort community, down past Pretty River, and then back towards Thornbury, creating sort of a rectangle. And traveling back and forth across the town to pull data and charge devices, it would be quite a resource-intensive task. Your fuel, time, and manpower would all contribute to a hidden cost. Whereas using the cloud and our low-cost data plans and cloud hosting fees enables the town with a limited budget to take advantage of these hidden cost savings provided by remote data access. So again, if you're a rural municipality and maybe you think a cloud hosted solution is out of reach because it's too expensive, I encourage you to reach out for a quote because our solutions are very cost effective for what they provide. And especially using the Armadillo tracker with the reduced amount of infrastructure required, it turns these temporary count stations into a real possibility. So at this point in the presentation, you may be thinking, well, what's exactly included if I decide to invest in an Armadillo for my community? So the tracker base model includes all required tools, mounting hardware, charging cables, and software for turnkey deployments, specifically including various sizes of banding and host clamps, a data acquisition cable for local data access, a high-speed AC charging cable for 120-volt AC charging, a USB car charging cable for charging your device in the car, and of course, free stats analyzer software on a USB key but you can also download it over the website. There are also a whole host of optional items which can be included with the tracker, and I will briefly go through those right now. First, you have the rugged weatherproof carrying case, which is a very popular option for clients, and it's shown here on the right. The case includes a foam insert, which comfortably fits all equipment between deployments. This makes organizing and storing the tracker equipment incredibly easy, and it also protects the equipment from the elements being, misplaced or abused in a warehouse somewhere. If you are considering multiple deployments before extracting the data, then you should consider GPS-based geotagging. GPS-based geotagging is a feature which allows each data set to be stamped with GPS coordinates. This means you can redeploy the tracker to multiple different locations before pulling the data, and then you'll be able to see each data set timestamped with a GPS record. This is very useful if you plan on moving the tracker around multiple locations before pulling the data, because you will see each vehicle record stamped with their associated GPS coordinates. Of course, the 10-watt solar panel is a bulletproof way to power the tracker indefinitely as a semi-permanent or permanent data collection station. Because of the tracker's ultra-low power consumption, which is 0.2 watts, and keep that in mind, you can be confident in the reliability of using solar as a power source. And finally, ordering with the built-in modem and SIM means you'll be ordering a tracker which comes with remote data collection capabilities. This option is almost always ordered with cloud hosting and the 10-watt solar panel. And this, of course, will allow you to pull the data sets remotely through the cloud, creating a near maintenance-free, cost-effective, permanent or semi-permanent count station. And now is an excellent time to order, because for a 60-day period, we'll be offering 10% off the base model and 1 year free Tetragon cloud services for both the Armadillo tracker and SpeedLane Pro. Again, any orders processed within 60 days of this offer, or May 8th, 2023, will honor the promotional rate. There's a code here in the webinar, and please include the code when ordering, or I'll just tell you the code if you want to order with a promotional discount. But again, 10% off, 60 days from today, a great opportunity to get into the market if you're on the fence. It's even cheaper than it normally is. And now we're going to have our skill testing question. So I hope you're paying attention, because there's a great prize on the line here. This bundle of Stinson goodies on the right includes a Yeti mug, Stinson notebook, a pen, a 64 gig USB key, and you get this bag as well. So I want to make sure this is fair for everybody. So I will reveal the questions and the options for answering in 3, 2, 1. Here we go. Hope everybody's ready. What is the power consumption of the Armadillo tracker? Please enter your answers in the chat. First one will receive the giveaway. So again, any answers, please enter them in the chat. And the question is, what is the power consumption of the Armadillo tracker? And you can type those in to the chat. The first person to type it in, the correct answer, of course, wins the Stinson giveaway.
So there are lots of answers already.
Great.
The correct answer was C, 0.2 watt. And the first person to answer was Jeff. So Jeff, I will contact you afterwards to get your mailing address so we can ship it out to you.
Excellent. Congratulations, Jeff. Select correct answer. That's great. So hopefully everyone has had time to digest the information from the tracker. And don't worry, we'll have time to get to all your questions at the end of this presentation. So keep them in mind, write them down. And now let's switch gears to our next topic, the SpeedLane Pro. The SpeedLane Pro is a state-of-the-art, true dual beam, low power side fire radar. It is designed to accurately detect lane, speed, and class of individual vehicles and compute per lane volume, occupancy, gap, average speed, 85th percentile speed, and headway parameters. The SpeedLane also supports 8 customizable length-based classification bins. Now, I briefly mentioned that the SpeedLane is a true dual beam side fire radar, and that's because the SpeedLane includes 2 FMCW side fire radars within its enclosure, one at either end of the device, effectively creating a speed trap. This feature is the primary reason why the SpeedLane boasts such high levels of data accuracy. Vehicle speed is accurate within plus or minus 1%, volume accuracy ranges between 98 to 99%, and length-based classification is roughly 90% accurate. The SpeedLane is an exceptionally well-engineered product, and its integration goes even further than the patented speed trap design. Within the SpeedLane's enclosure includes dual side-fire radars, a high-definition megapixel camera, a built-in battery backup system, a solar charge controller, an optional integrated modem, a PoE injector, and a Bluetooth receiver. And now, if you think all of that is impressive, consider the SpeedLane only draws 0.9 watts of power. And this power can vary to 1.2 watts, depending on if the modem is active or not. But between 0.9 and 1.2 watts of power is 10 times lower than the closest competing radar system. This means solar deployments, even in our harsh climate, are not only possible, but the most common method of deployment with the SpeedLane. Data collected by the SpeedLane is typically stored and accessed using the Tetraon cloud. And again, as I mentioned, the cloud is very convenient. It's a great way to access data from multiple SpeedLanes from the comfort of your office, and it includes numerous pre-built Excel and graphical reports along with access to the raw data. So this image right here is a cross-section of the SpeedLane Pro, and it shows just how well integrated and engineered the device is. As I previously mentioned, the housing includes 2 side-fire radars, one here and one here, an HD megapixel camera. This is used primarily for aligning the radar and periodically checking in on the alignment after installation. A Bluetooth receiver for local configuration and data validation. You can pull up in your truck to the SpeedLane from about 800 feet away and access this receiver to configure the device locally. It includes an optional integrated cellular modem and GPS. Again, this is an optional feature, and some of our clients choose to use an external modem in a piggyback cabinet. An optional PoE injector. So if you wanted to have a power over Ethernet application or transfer data from the SpeedLane to an external modem, you can do that with the PoE injector port. An optional digital video recorder, which records 18 hours of video. A battery protection system. A solar charge controller. Again, you can choose to use an external solar charge controller if you don't want to use the internal one. And finally, a Life PoE4 battery backup system, which can power the device for 4 days in the event of an outage. As I mentioned, power consumption for this device ranges between 0.9 watts and 1.2 watts, depending on whether it's in standby mode or the modem is active. And the weight of this whole enclosure is only 6.5 pounds. Now, I want to briefly discuss the operation of the SpeedLane Pro. Unlike the Armadillo tracker, which includes a Doppler radar, the SpeedLane Pro includes 2 FMCW side-fire radars located here and here. Therefore, the device is mounted on the side of the road, perpendicular to traffic, as opposed to facing traffic head-on. FMCW stands for frequency modulated continuous wave, and it's a method of radar detection which involves measuring the frequency shift between sent and received radio signals. This method is considered more accurate than Doppler radar, but it consumes slightly more power. Vehicles traveling through the SpeedLane's field of view are captured by both radar beams, effectively creating a speed trap. This speed trap configuration is quite common on our highways, but typically done with pairs of inductive loops milled into the pavement, collecting vehicle data by measuring the time between hits and then computing velocity. You can think of the SpeedLane in a similar way, except the loops are virtual or non-intrusive. In terms of mounting height and offset, it is generally advised to match the mounting height of the SpeedLane to the offset of the distance to the first lane, or the offset to the first lane. Again, this is a guideline, and please feel free to consult us if you have an application where there's not as much offset or you can't mount the SpeedLane sensor as high, because generally there's something we can do to make it work. It really depends on what lanes you want to measure and how far you're measuring with the SpeedLane to really determine that offset. But as a guideline, this is a very safe guideline to follow when mounting the SpeedLane Pro. Data captured by the SpeedLane is uploaded to the cloud, and the upload occurs typically every 15 minutes. This can be adjusted to every 60 seconds if a real-time application is requested. And finally, the cloud can be accessed through any secure browser from the comfort of your office or home. No local software is required. SpeedLanes may also be integrated into an existing advanced traffic management systems infrastructure to route traffic data into a common database if you're a larger municipality. Certain ATMS applications, such as congestion management systems, can also be realized using the SpeedLane. For instance, installing a SpeedLane upstream of a busy intersection and then passing triggers from the SpeedLane to that intersection's traffic controller based on elevated traffic densities or congestion could create a responsive control system without investing heavily in adaptive traffic control infrastructure. Another application I want to talk on where the SpeedLane proves to be an excellent sensor is in automated queue warning systems. Automated queue warning systems have been on our highways for a very long time, and they work by monitoring the speed of vehicles along a stretch of roadway and then providing a warning to motorists, approaching motorists, when slowdowns or stopped vehicles are detected. These systems have traditionally been installed using permanent inductive loops for detection, but with advances in solar, wireless technology, and sensor technology, these systems can now be deployed in temporary applications for work zones, effectively creating a smart work zone. These systems are heavily influenced by the estimated queue length, and of course, the purpose of your queue warning system. There are various configurations in the industry. The 4 sensor plus 1 PCMS board set up below, that's shown here, is typically called a level 1 queue warning system, and it's suitable for monitoring about 2.5 to 3 kilometers of queue length. For this layout, the SpeedLane Pro sensors are staged roughly 1 kilometer apart, covering the estimated queue detection area. The PCMS sign is then staged roughly 1 kilometer upstream of the queue detection area, such that slowing and then slowed or stopped traffic is detected by the SpeedLane Pro sensors, and then those triggers are passed to any open protocol ATMS software. You could use Genetec, you can use ITS Central, Vermac, Icon, any ATMS software which is configured with the SpeedLane protocol, SpeedLane's open protocol will then post that message to the PCMS board, warning the drivers approaching the work zone that traffic has stopped or slowed. Queue warning systems help drivers anticipate upcoming situations of emergency braking or slowdown. They help drivers avoid erratic behavior and queue-related collisions. And queue warning systems have been proven to reduce accidents up to 45%, delay the onset of congestion, and increase road safety for construction workers. At this point, I want to see if I can squeeze in a really quick demonstration of the Tetrion cloud. So let's do this quickly because we're running out of time. Okay, so this system here was deployed for the Northwest Territories, and each SpeedLane was deployed using AC power as opposed to solar, as Northern Canada really does not receive enough sun for solar applications. And I wanted to show this one in particular because it's a really unique project for Stinson ITS. However, I can't pull any reports or modify any of the reports in the system because it is a client system. I want to maintain the integrity of their database and client confidentiality. So the tab I'm showing right now is the summary map. And the summary map includes placement of any cloud-enabled Houston radar device in your network. And for this client in particular, 12 sites were installed. And we worked with a local electrical contractor to get them installed because it's just too far away from Toronto for us to be there for every installation. But because it's so simple to install, you know, these guys got understood it immediately, and we had these up and installed very quickly. What's cool is we have a system that's actually as far north as a town called Inukvik. So this is our furthest north SpeedLane site, probably the furthest north SpeedLane site that we've ever deployed, and that's really close to, I guess, the Arctic there. What's also interesting in this in the Tetragon Cloud platform is that you can view live radar data. So I'm going to click on one of these sites, and we'll see what we can view in terms of live radar data. So this site in particular includes 2 lanes, and the client has customized their dashboard to display speed and volume per interval, where the interval has been set to 60 minutes, occupancy per interval, 85th percentile speed per interval, and the voltage levels of the SpeedLane Pro, because power is a concern up there. So they want to monitor their voltage levels. So of course, within this platform, you can customize this dashboard however you'd like it, with multiple graphs being shown at once across a wide variety of live statistics. One thing that's cool as well about the SpeedLane, about the Tetragon Cloud platform, is the alert section. So within the alert section, you can configure alerts when certain thresholds of the SpeedLane operation are breached. In this case, the client has configured a voltage alert to alert Stinson support when the voltage levels drop below a certain threshold. Thankfully, this hasn't happened yet, but if it does, the support team here at Stinson will receive the alert and respond as soon as we can. And here you can create new alerts as well. So if I click this Create New Alert tab, we can see a whole host of parameters that can be custom configured to trigger an event, or trigger an email, or even take a camera snapshot of the from the SpeedLane and store that along with the alert. So some pretty cool alerts that can be configured, and especially useful for solar. If you want to configure alert that alerts you when your solar battery levels are getting too low, you can easily do this in this platform, and it will be emailed to Stinson or your contractor or anybody really who needs to be alerted that specific alert. And the final thing I want to show here before we get back into the presentation is the historical data. This section right here I'm showing right now is live. This is coming live from the radar, but here we can also view historical data. So when viewing historical data, again, we get to select the interval level, the amount of days of data we want to pull, and this can go back indefinitely. We indefinitely store our data on the Tetragon Cloud platform, and we can pull graphical reports like what you see here, which is again another voltage report, or we can even pull raw data CSVs. I'm not going to pull one right now from this client, just because it is a client system, but a raw data CSV will give you a record for every vehicle that's passed by the SpeedLane, giving you their individual speed, classification, lane placement, gap, and headway parameters. And this is a very popular file for municipalities to really get a granularity in their data reporting. Okay, so at this point, it's 1:45. I promise we're almost done the presentation, but if you have to go, don't feel bad if you have to leave. We'll have a recording. We'll have it on YouTube, and I'll make sure we get that recording out to everyone who attended or who wanted to attend and couldn't make it. So again, it's 1:45. If you can stay on, that's great. It'd be great to have you. But if you can't, don't feel bad if you have to leave. To end our section on the SpeedLane Pro, I want to just talk briefly about our solar capacities. So Stinson ITS, we manufacture and design all SpeedLane Pro solar systems in-house. And as a matter of fact, we design and manufacture all the solar systems that we'll use in-house. This gives us a strong competitive advantage as we can provide turnkey, custom solar solutions provided by a strong manufacturing and support base. As the SpeedLane consumes 10 times less power than competing radar devices, they can be supported with a minimum spec 50-watt solar system. However, as this is Canada, minimum spec solar systems have a lot of trouble achieving their desired functionality and experience frequent outages. And we've concluded over many years of working with solar applications that it's always best to over-engineer a solar system to account for extensive periods of darkness or a low UV index. As a result, we've intentionally over-engineered our solar solution to account for our challenging climate. And while this may slightly increase the costs, the benefits in terms of autonomy and peace of mind are too large to ignore. Our standard solar system includes a vertically mounted 100-watt panel. It is mounted vertically to reduce the likelihood of snow building on the panel, therefore reducing maintenance costs and increasing reliability. We also include 2 48-hour AMG batteries, which equals 96 amp hours in total. This equates to roughly 10 days of autonomy, and if you factor in the additional 4 from the battery, we get around 14 days of solar autonomy. That 4 is coming from the internal SpeedLane Life PoE4 battery. In the image here, you can see our cabinet, which is used to house the solar equipment, 2 batteries, the charge controller, and in some cases, an external modem. And in this case, there is an external modem right here mounted on the side of the cabinet. This package comes delivered, turnkey, prefabricated. All the contractor has to do is mount the device on the pole and plug in the connections. The final section of our presentation will focus on a few key case studies, and this one was for the region of Peel. And you know, it's kind of a common theme among all of our regions and cities in Canada. As our population in our towns and cities continues to rapidly grow, collecting traffic data is becoming more and more important. Continuous year-round traffic data is needed for our communities to make informed decisions about mobility trends, infrastructure planning, and traffic calming measurements. The region of Peel is a great example of this. If you aren't familiar with the region, it's a large municipality located here in South and Southern Ontario. It's home to roughly 1.4 million residents, and in the past, the region conducted annual traffic counts using 1 to 7 day temporary road tube deployments. So while temporary road tubes traffic studies are a very traditional method of traffic data collection used by nearly every municipality in some way, there are some very clear challenges which the region noticed and began seeking a solution for in 2017. And we all are somewhat familiar with these limitations. Firstly, they're very dangerous for road crews to be out in on the road laying these tubes, especially when you have a 6-lane collector road. They degrade very fast over time, especially in the winter. They do not allow you to conduct year-round data collection because of winter operations, snowplows hitting the tubes, and you know they cost money because in terms of your labor, manpower, and time traveling to site to pull the tubes out of the ground and pull the data collection, use the data collector to gather the device data. So you know a combination of these factors led the region to search for a non-intrusive option which could accommodate for year-round operation regardless of weather conditions or traffic conditions. So in 2017, the region approved the first 10 SpeedLane sites, and these are permanent data collection sites deployed with solar panels, internal modems, and a connection to touchscreen.
Okay, the next question. Let's say the offset is 8 feet, but the pole in question falls into a 2-foot culvert. Is the mounting height still 8 feet, or do you need to add the extra 2 feet from the culvert depth? You should, the answer to that question is yes, you should account for geographical features when installing the tracker. So the culvert depth would have to be taken into account when installing the tracker, and if it's deep, if it's an extra 2 feet deep, then you should add an extra 2 feet to the mounting height. Do all solar panels have the touch-around cloud built in? We have solar panels, but did not know they supported remote data access. I'd love to learn more about this. So not exactly, this touch-around cloud is not built into the solar panel. The device itself, for instance, the Armadillo, would have to be ordered with the built-in modem. So when you order with the built-in modem, and you connect to the solar panel, then you can use the built-in modem in the tracker to remotely access the cloud. Okay, another question here. Do you recommend using the Houston radar for mid-block locations between traffic lights that often see queuing? If not, what product would you recommend installing in these situations? Great question. It really depends on what the queuing looks like between those two traffic lights. But if there was heavy queuing and vehicles were frequently starting and stopping, then I would recommend not deploying an Armadillo tracker. But there are other solutions that you can look into, and I'd be happy to take those solutions offline with you for this website. Sorry for this this discussion, and I can reach out later on, and we can certainly discuss some options for temporary installations for these situations. Okay, so Tanner, okay, yeah, good question as well. Okay, yeah, great. We'll definitely get back to you with this recording and any answers to the questions that I wasn't able to answer here. We'll get back and we'll talk about the price. And thank you again. Oh, I got another question here from Travis. is there any way to get quicker upload of data than the 60 seconds? It's a great question, and unfortunately, 60 seconds is the maximum. It was the minimum amount of time that we need to send data to the cloud. So yeah, that's as close as we get is 60 seconds. I don't believe you can get any further resolution from 60 seconds, but something I can talk with Houston Radar about, and we'll get back to you on that. So I'll wait another minute here, but if there are no questions, any more questions, then I can let everybody go for the day. Again, thank you very much for your attention today. I really appreciate it, and apologies for the technical difficulties. I think everything worked out in the end though. So again, if you want to reach out to me for a quote or anything regarding Armadillo Tracker, please feel free to get in touch with me. My email is harrison@stinson.ca, and I'd be happy to address any questions or provide a quote at our promotional 10% discounted rate. Thank you very much. I hope everyone has a great day.